This lesson is going to examine exponent rules, in particular ones that involve exponents that are integers, whole numbers, positives and negatives. Some of these we looked at back in grade 9. It's been a while since we did those, so we're going to review them and add one or two little new rules in. The whole idea of exponent laws is we want to simplify expressions that involve multiplication and division. Okay? These only work with multiplication and division. They do not work with addition or subtraction. If you come across that, we got to use BEDMAS. Whereas we do exponents first before division, multiplication, addition, or subtraction. Okay, so let's look at the ones we learned in grade 9. You might remember. Okay, if we have bases that are the same and they're multiplying, we can simply add our exponents. So a to the m times a to the n will equal a to the m plus n. For example, 2 to the 2 times 2 to the 3 is the same as 2 to the 5. And if you really wanted to, you could write that out. 2 times 2, that's 2 to the 2, times 2 times 2 times 2, that's 2 to the 3, and hopefully you notice we got 2 to the 5. If you divide bases that are the same, you can subtract your exponents. Okay, so a to the m divided by a to the n would be a to the m minus n, or 2 to the 8 divided by 2 to the 3 would be 2 to the 5. We can subtract our exponents. If we have a power of a power, we're going to multiply exponents. So a to the m to the n, we can just multiply those things. So 2 to the 3 to the 4 is 2 to the 12. And that one you might remember if we write out to the side here. 2 to the 3 means 2 to the 3, sorry. 2 to the 3 to the 4 means that thing 4 times. Well, that takes us back to this rule, right? 3 plus 3 plus 3 plus 3, or in other words, 3 4 times is faster to multiply. And our other basic rule, the zero exponent. It always equals 1. Regardless of what your base is, if it's the power of 0, it comes out to a 1. So I could have 2 to the 0, or a to the 0, it comes out to 1. Those were our 4 sort of basic rules we learned back in grade 9, but we didn't do much of those in grade 10. We're going to try simplifying some things. Practice these ones. So, simplify means make it easier without actually calculating what it is. You don't need a calculator for any of these. I don't care what 2 to the power of 7 is. I do care that 2 to the 7 times 2 to the 4 comes out to 2 to the 11, because we should add our exponents when we multiply our bases. And all you need to show me is this piece, okay? I don't need the part in between. That's something we should be doing in our heads. I'm going to show it right now so we understand what's going on. We should do in our heads. 3 to the 7 to the 4, I should be multiplying my exponents. It's a power of a power. So that comes out to 3 to the 28. The next one, I've got a two-stage problem here. I need to figure out the top part. I need to add my exponents. Rule number 1 gives me 9 to the 9 over 9 to the 3. And then since I'm dividing, I should subtract my exponents and get 9 to the 6. If we try the next one, I've got something in brackets to the power of 4, which means I need to apply that 4 to everything inside the bracket. A power to a power gives me x to the 16 and y to the 8 because we are multiplying. Just make sure you multiply both. If we use that idea in the next one and I see a power to a power again, I need to multiply those things. The way that's going to look is 2 times 2 plus n. Well, that's distributive, right? We can distribute that and get x to the 4 plus 2n. So we can combine algebra with exponent rules. If I look at the next one, again I see a power to a power. I make sure I apply it to the top, but also the bottom. So we'll get a to the 6 on top, and 3 times 1 makes b to the 3 on bottom. It's in a bracket. We've got to apply the exponent to all the parts of the bracket. Next step. What do we notice here? P to the x plus y times p to the x. What am I supposed to do when I multiply bases? I'm supposed to add my exponents. So I get p to the x plus y plus x, or in other words, p to the 2x plus y. You can do the same thing in the next one. I have the same base, they're all multiplying. So I'll get x to the power of a plus b plus b plus c plus a minus c, which comes out to 2a's and 2b's, and the c's cancel each other out. Letter I could simplify all the stuff inside the bracket and all the stuff inside the bracket, but I notice the whole base to the power of 0. That comes out to 1. It's almost like a trick question. Okay, and then the last one. Now the last one, I'm hoping you've noticed a plus sign. If there's a plus sign, okay, star beside that, I have to go back to bedmass. I have no choice. As soon as I see pluses and minuses, you're done with exponent rules, bedmass rules. What do I store with bedmass? The stuff inside the brackets. So the squared on the outside has to stay the squared on the outside. Inside the bracket, I can do 10 squared to make 100. Then I could add my bracket together, or sorry, the parts inside the bracket, and put my exponent on it. And then I finally get to start that exponent rule and get 12,100. Okay. You see a plus or a minus, stop with your rules. You can't simplify that way. You actually have to evaluate. A new rule for us today. We're going to talk about negative exponents. To do that, we're going to figure out where negative exponents come from. So, I hope you would agree that 2 to the 4 is the same thing as 2 times 2 times 2 times 2 over 2 times 2 times 2 times 2 times 2 times 2 times 2. I'm writing it this way for a reason, so we can see where the exponent's coming from. Okay. Based on exponent rules, what should we do when we divide? We're supposed to subtract. So 2 to the 4 divided by 2 to the 7 comes out to 2 to the 4 minus 7, which is 2 to the negative 3, a negative exponent. We know from 2 units ago, rational expressions, when things are multiplying and they're on the top and the bottom, we can cancel them. So I can cancel a bunch of 2's, 4 from the top and 4 from the bottom, which I hope you would agree with me. It leaves me just the number 1 on top, and the 1 because I've canceled everything else out, but there's still something there, right? It's a 1. And on the bottom I have 2 to the 2 times 2, or in other words, 1 over 2 to the 3. So we can say mathematically that 2 to the negative 3 is the same as 1 over 2 to the 3. And that's going to be true for every situation that involves a negative exponent. So if I come across 3 to the 2 divided by 3 to the 5, I know I can subtract them. I know I can get 3 to the negative 3, and I know that actually means 1 over 3 to the 3. Okay, here's our little rule. Move it down just a little bit for us. A negative exponent is equal to the reciprocal to the positive exponent. So what does that mean? Well, reciprocal means flip the base. So if I have a base of x is actually in brackets, to the negative a, I can flip that base over, think of it as being x over 1, that gets me 1 over x, and make my exponent positive. And when I apply that exponent to the top and the bottom, like we're supposed to do, I get 1 to the a over x to the a. Now the nice thing about 1 to the a, 1 to the power of anything, is always 1. So a shortcut idea is saying if you see a negative exponent on the top, take your base to the bottom and make your exponent positive. Okay, we're going to try some, see how this works. If that doesn't quite make sense yet, let's try some things. So I see 6 to the negative 3. Okay, that's a negative exponent, so I make a fraction. My base goes on the bottom, my exponent becomes a positive, and there's a 1 left on top. That's it. Done. I'm rewriting these with positive exponents. Try the next one. Oh, I got a multiplying bases. I need to add. That gets me 3 to the power of -7, which I can write as 3 to the 7 on the bottom and a 1 on the top. I flipped my base. The next one. Oh, I've got 1 over 3 to the -2. We said we should be able to write this on the bottom, but I've already got a fraction. So let's talk about that. I have 1 over, and I got to take this and put it on the bottom, right? 1 over 3 to the 2. So if we deal with fraction rules for a second, I hope you would agree this means 1 divided by 1 over 3 squared, which when we think about fractions means 1 times 3 squared over 1. Or in other words, 3 squared over 1. Or in other words, just 3 squared. So here's your sort of second idea with this. I started off with a 3 to the -2 on the bottom, and it became 3 to the +2 on top. So you can take exponents and move your bases from the top to the bottom of a fraction, if you have a negative exponent, or, in this case, from the bottom to the top and make a positive exponent. So with that in mind, if we look at letter D, I see a negative exponent on the bottom. I move it to the top and make it positive. Now notice I didn't change the number, or sorry, the sign, right? It's still a negative. It's a negative number. That's fine. It's negative exponents that we don't like. Okay? Now, some things to be careful about. If you get a fraction, and the whole fraction is to a negative exponent, we can do that by writing the reciprocal to the positive exponent. So in this case, I got 2 over 5 to the -2. I could think of that as 2 to the -2 over 5 to the -2, which means the 5 goes to the top, becomes positive exponent, and the 2 goes to the bottom. Or more simply, what we often do is you just flip the fraction. That's the same thing. Okay? So if your whole fraction is negative, flip the entire fraction, make your exponent positive. What you might have to be careful about sometimes is noticing which bases are negative and which are not. Okay? Negative exponents causes some issues, but you have to really look at the expression and figure out which things are negatives. So if I look at this one, I see a to the -3, I see b to the 4, and I see c to the -2. If I want to simplify that, the ones that cause problems are the a, because it's a negative exponent, and the c, it's a negative exponent. The b is fine. B to the 4, great, positive exponent. So it's going to stay where it is. But the fact that a is negative on the top means I can move it to the bottom and make it a positive exponent. And the c being negative on the bottom means I can move it to the top and make it a positive exponent. But things that are the way they want to be, positive exponents, don't have to move. Hey, don't just flip your entire fraction when you see negatives. Think about which things. In the previous example, the entire fraction had the negative exponent, right? That's why the whole thing flipped over. In the second example, only parts of the fraction had negative exponents. So only parts got flipped over. Okay, we're going to try some more. I want to rewrite these things with positive exponents. So I see a -3 on the whole fraction. I'm going to flip my fraction. Okay. Notice I didn't change the negative sign on the number. Negative signs are fine. Negative exponents are not. Look at the next one. I see a fraction, but my negative exponent's only on the y. So only the y has to move. x3 is fine. Y is negative on the bottom. I bring it to the top. What's left on the bottom? Well, when we move things, there's always a 1 left. Now, we don't usually show that. We would just write this as x3, y5. Because when you divide by 1, it doesn't actually change anything. Let's look at the next one. I see a negative exponent on the top and a negative exponent on the bottom. That means both parts have to move. The A has to come to the bottom, become a positive. The B has to go to the top, become a positive. Done. Okay, we're trying to get positive exponents. All right, last piece. I want to simplify, and now I'm going to evaluate. So I want to actually calculate what's going on at the end. Okay, but I don't want to punch a whole bunch in my calculator. I want to punch in just a little bit. So that's why I want to simplify first. So exponent rules. I see them multiplying, so I'm going to add my exponents. That gets me 3 to the negative 1. I don't want to deal with negative exponents until I have to deal with negative exponents, usually at the end of a question. Okay, so try to simplify first before you worry about that negative exponent. What is 3 to the negative 1? We know that's 1 over 3 to the 1, or in other words, just 1/3. There, we've evaluated. Try the next one. I see a power to a power, so I'm going to multiply. That's going to give me 7 to the negative 5. Oh, negative exponent, don't like that. Let's flip it. 1 over 7 to the 5. The 1 stays the same. I use my calculator. 7 to the 5, 16,807. Let's try C. Ooh, there's a messy one. What do I notice about all these things? They're powers to powers to powers. So I can multiply all of those things. My base is the number -6 in brackets. Make sure it's in brackets because I want to apply the exponent to everything in the bracket, the number and the sign. And when I multiply -1 times -2 times -1, I end up with a negative and a 2. Oh, a negative exponent. I flip that. My base stays the same, still -6. Numbers are fine. My exponent becomes positive. So my answer is whatever -6 squared is on the bottom. And 2 negatives make a positive, so 6 squared is 36. And last one, letter D. Put it all together. Okay, where do I start with this? A bunch of messy things. Well, on the left-hand side of this, I see a negative exponent. And since I can't simplify inside the bracket, all I can do is deal with the negative exponent. So I apply it to the top, and I apply it to the bottom, or I just flip the fraction. That made life easier. In the right-hand side, I've got a bunch of parts and pieces going on. When you have a situation such as this, we go back to BEDMAS. And I don't mean BEDMAS because we're adding and subtracting. I mean BEDMAS in terms of what should I do first? Can I simplify inside the brackets? Sure I can. If I simplify inside the brackets, I can subtract these exponents. I'll get 2 to the power of -1 all to the 8. If we keep going, 2 over 1, well, that's the same thing as just saying 2 to the 4 times, I see a power to a power. I can multiply those. In other words, I can apply exponents to exponents next. That's going to get me 2 to the -8. I can keep simplifying. I've got bases that are multiplying. I can add them together. I get 2 to the -4. I don't like negative exponents, so I can flip it, and then I can calculate. And 2 to the 4 makes 16. So I don't want to work with exponents until don't want to evaluate exponents until I have to. The last stage of your question, hopefully. Okay. Little refresher, introduction to some new kind of exponents. Here's our homework for today. For 1 to 6, just do A, C, and E as appropriate, as they have an A, C, and E. If not, then don't worry about them. And try number 10. And that's our first lesson with exponents.